Hello, everyone. This is the 2024 version of the how to write a neural network in PyTorch. And let me share my Colab screen. Okay, so we have seen PyTorch and we have seen how to write neural network before. So this is just a summary of it. First, it's just the basics of checking whether Google Colab is running. I'm running it in Colab, so it should be yes. And then we import the PyTorch and just check what program we are running. I'm basically running GPU CUDA. All right, so just a simple quick introduction to PyTorch. PyTorch is a language that can do linear algebra very well. And what you can see here is that I can create a 3, 3 or kind of a vector or 2, 2 kind of value vector, and I can do a dot product multiplying these two. And it will give me, well, 6 plus 6 is 12. Also, I can do subtraction options, a vector 1, 2, minus 3, 3. I can do subtract here, subtract. And not surprisingly, it gives you -2, -1. I can individually change it. So previously the x was 1 and 2. Now I'm changing it to 4 and 6. And then do a subtraction. And I'll get a new value here. Okay. So these are the kind of thing that PyTorch is really good, and neural network uses a lot of linear algebra. So this is why PyTorch is kind of useful in doing this. To clean up the data, again, we have done this in pandas a lot, but here I'm basically showing you a little bit of basics. So here's an income evaluation file. Let me just load that. Reading it for Panda. And it has various data items. And you can see like race or sex, these kind of are not numbers, and we need to convert them to numbers, as well as if they're missing, clean them up, and all this. So what you can do is here, for example, for race, if you want to use the race, and there are probably several categories, how do you do this? Well, in pandas, you have to get dummies and then call the race. So what it will do is that it will create a race, and then all these items here, race black, race other, race white, something like this, it creates them. You can concatenate to put it in your original file here. All right, so now it's being all added on top of the existing data we had before. All these race variable dummies are indicated here. Fill in the missing values. Ages are sometimes missing. Then put a median in here. You can also delete many things pandas can do. And then eventually neural network, all the numeric values has to come in. So for this example, I'm just going to ignore the non-numeric values like work class, education, marital status, occupation, relationship, sex, something like this. So drop all of them. I can just turn to call this variable df and then drop. And then for the income, I have income is basically above 50K or below 50K. Where's income? Here, below 50K, above 50K, something like that. So this binary variable, I can just label and try to create the high income indicator for this. All right. So if you look at the X and Y's, you can see that here are the numeric values, and here I have the income, true or false. So, so this is how you clean up the data. And if you don't feel comfortable, certainly you can use Excel and other things, but in Pandas, it's very flexible. So you could see here some examples of how to do these, right? So there are two neural network examples how to do it in Python, and we have done this in Keras, so Boston housing prices, for example. The prices are continuous variables, so we'll have a linear activation at the end. So let's import the libraries. and load the Boston housing data. We have done it many times, so I'm not going to spend too much time. And then in pandas, I can create, so for all these items, the columns for the axis, I get the values to get in here to create a list, and the median value in the Y, do this. And then I create a torch tensor of the X and Y. So this is how you use the torch tensor function. So now here's the part to create a neural network. So I could name it model, and then the NN, the neural network PyTorch sequential. And it uses first the linear activation, the X of shape, so the number of input columns, go to the 50, and then rectified linear unit, and then to linear 50 to 25, and then rectified linear unit, and then 25 to 1. So this is my neural network. And then what I do is that I try to compile it, and then the loss function is defined. You can do custom define, but here I'm just using mean square error loss and call it loss function. And then the optimizer is Adam optimizer here. So this is how you call it, torch optim Adam, and then give some other parameters. All right. So let's train it. The training in PyTorch is a little bit more explicit. So you have to call a for loop of how many epochs you're going to run. And then the optimizer we defined here. First, we set to 0 gradient. So anything from the previous round, we want to set to 0 and then flatten the gradients. And then here's the model prediction given the X. Give the model prediction and then put in the output. And then that output and the actual Y will be compared in the loss function here in terms of mean square error. We name it loss. And then the loss backward computes the gradients. And then the optimizer step changes actually the updates the weight. And then you do this for, for 1,000 epochs. And it's rather fast. So it's all done. So, and then once it's trained, you can do many things. You can just put an X and then predict the model. I will give a prediction. You can, for example, compute the mean square error of the prediction. Here's a technical thing. You need to detach from the model so you don't alter the model itself. So when you get the prediction and Y from an external function like scikit-learn, you detach this prediction and Y. The CPU is there just in case you used a GPU, then you have to convert it to a CPU version of it and then detach it. And you can use the scikit-learn functions to compute the mean square error. If you can, of course, PyTorch supplies the same function here. So torch neural network functional MSE loss, and then prediction here, flatten it to match with Y dimension, and then Y can just directly call it, and it will give you the same thing. Okay, so this is how you do it for continuous variable like prices. You can also do it for 0, 1 variable like classification problem. So, and one thing we did was the loan defaults. So load the data and panda data frame. So their employee bank balance annual salary, put into the X, and the Y, the defaulted variable, you put in the Y. Okay. And then convert to PyTorch tensor as an input. And again, this is the same, almost. So you put the shape 50, 50 to 25, 25 to defaulted. Defaulted is the 1, 0 variable, whether it's defaulted. And then you put it into softmax. In this case, it's output is 1 variable, you don't have to. But if there are multiple categories, then you need the log softmax to do here. And then there's this model. Criterion is the loss. So if here we use cross entropy loss, and then the optimizer is Adam optimizer. And then the training, very similar. So the model train. So you have 1,000 epochs. The optimizer set the gradients to 0, and then the model predicts the output. And then the loss is computed based on the cross entropy, binary cross entropy, Y and out, and then compute the gradient and update the weights. And it printed every 100 times. So you get it. You can do evaluation of the model prediction and see whether they're correct or not. And there are a couple of things you can do, but in general, classification works something like this. You can do the accuracies and also put some sample borrows and compute the accuracy and then these kind of things. All right. So this was just a simple review on how to use, how to create and run simple neural network using PyTorch. Thank you for watching this episode.